Hi everyone, very good evening to all of you. Welcome to Vedantu NEET English. How are you all? Very good evening everyone. Very good evening. How are you all? How are you all? Let us wait for students to join in. Let us wait. Let us wait for students to join in. So guys, today we are going to do aromatic, non-aromatic and anti-aromatic. Now, after this, all the stability factors will be done and we are going to do acidic character, basic character and stability of intermediates. Right? But for that, you need to know what are these electron displacement effect, that is inductive effect, hypoconjugation effect, resonance effect, and then inductive hyperconjugation, resonance, mesomeric, electromeric effects, and after that, aromaticity. Right? Okay. Very good evening, bacho. Very good evening, everyone. Very good evening. Very good evening. Duration. Okay, so the duration will be not that much. It's a very small topic. It's a very small topic and very easy topic. Trust me on that. It's a very easy topic. I told you now, hyperconjugation and aromaticity are easiest of all. Okay, so shall we start the lecture? Shall we start the lecture? Why they are not students? Where they are? Where are the students? Where are the students? Huh? Not interested or what? So have you watched my video where I have, combined all the topics that are excluded from your syllabus and that are excluded from your syllabus, but you still need to do those topics. I've included both of them, right? Okay. Is there any lag? Is my voice audible to everyone? Is my voice audible? Yes. Okay. The chat is so dull right now. The chat is so dull, yeah. So boring. So boring. So boring, you students. Very boring. Where are other students? So I guess they'll watch it live or whatever. I don't know. Maybe recorded. Okay, so let us start. Shuru karte hain. Let us start. Aromatic, non-aromatic and anti-aromatic. So about the aromatic, for aromatic, firstly let us decide the conditions for aromaticity. So there are basically, so very good bacha, very good. So there are basically three conditions for aromaticity, that is planar, complete conjugation and cyclic. So firstly let us see what do you mean by these three conditions. If there is, I call this PCC. I call this PCC. Wait. I call this PCC. What is PCC? PCC is Priyanka Chopra. Okay? PCC is Priyanka Chopra. PCC. Okay? You have to remember this by PCC. Planar, complete conjugation and cyclic. Okay? So firstly, the compound must be planar. Second thing is it should have complete conjugation throughout the ring, right? And then there should be cyclic. Right? So firstly, let us understand what do you mean by complete conjugation. What do you mean by complete conjugation? So guys, see, if I am taking these two examples, in one example you have these two double bonds and this is positive and this is positive. In one position you have this and in the other position, in the other compound you have this thing. Other compound you have this thing. You have this thing. Wait. You have this bond and this bond. So now, out of these two bonds, what you will see, this bond is like, this compound is like this. In this compound, you have a complete conjugation here. Right? There is complete conjugation in this compound. But in this compound, there is no complete conjugation. For example, let us take another example. I am taking another example. You have this thing and then you have this thing. Then you have this thing. Right? Then you have this thing. So, even in these two compounds, here there is no complete conjugation. Like you have double bond, single bond. Okay? Then single bond, double bond, single bond. You need to have double bond, then single bond, then one p orbital or alternates double and single bonds for complete conjugation throughout the ring. Right? So, there is no complete conjugation. Right? So, that is why it is not following the pattern. And this is complete conjugation. So that means it is following the condition of complete conjugation. Right? Okay. So we will directly neglect this because this is not complete conjugation. And if I talk about this planarity. For planarity, let us understand this. You know, sp2 hybridized orbitals are, what is the hybridization sp2? What is the geometry of this particular hybridization? It is trigonal planar. That means they will be on one plane. One plane, the atoms will be aligned in the one plane, right? That is trigonal planar. That is trigonal planar. Trigonal planar. Just give me a minute, Diksha. Yes, that is trigonal plane. So now let us understand one by one what does all these things mean, right? So first is carbocation. If I talk about this thing, you have CH3 positive. Now tell me of this CH3 positive, if I talk about this CH3 positive, and I'm talking about this CH, then CH, then there is double bond CH2, right? 2, and this is 1, 2, 3, 4, and this is CH2 positive, right? Here is CH2 positive. Now, you need to tell me what is the hybridization of these two compounds. What is the hybridization? Write the definition. Nobody is going to ask you definition, but so nobody is going to ask you definition. Okay? Nobody is going to ask you definitions of these things. Right? These are not going to come in your paper. What is definition? This and this. This is not 6th, 7th class. Okay, you are preparing for NEET. Okay. So now tell me what is the hybridization of these two things. What is the hybridization? Took leave for this class. Oh my God, that's so sweet. Don't worry, I'll solve your problem. The class will be from the next week. The class will be Tuesday, Thursday, 6 p.m. That will be convenient for you as well. Right? Okay. So guys, see, this is CH3 positive and this is this compound. Now, let us see this CH3 positive. What is the hybridization? What is the hybridization, bacha? As you know, this is having 3 sigma bonds. If you have, this is lone pair plus sigma bonds, and this is the hybridization. And this is the hybridization. So for lone pair and sigma bond, the summation of this, if the summation of this is 4, then this is sp3 hybridization. If the summation is 3, then it will be sp2 hybridization. If the summation is 2, that will be sp hybridization. Right? So let us understand this. This is having 3 sigma bonds, no lone pair. Right? So that means it has sp2 hybridization, isn't it? Right? This is having sp3 hybridization. Yes. Yes. Okay. So, bacha, after this, now let us see. Let us see this. This is the double bond. This is the single bond. Bacha, I'll take care of that in the chapters itself. Okay. In the hydrocarbons and all these things where definitions are needed for you to understand, I have put the definition in those slides, okay? In those slides, definition is there, right? So understand this. This is double bond and single bond. Will there be any conjugation? There will be a conjugation. This particular bond is having delocalization, right? So this bond will jump here and the resonance will be, the resonating structure will be CH2, double bond, CH, and this is CH2, right? So these are the two resonating structures. That means this positive charge is actually delocalized, right? The positive charge is delocalized here. It is firstly here on this carbon and then on this carbon. So now that means that on this particular carbon, if I talk about this carbon, I am highlighting it as pink. I am highlighting it as pink, okay? If I am talking about this pink carbon, then the hybridization here is 1, 2, 3, that means sp2. And the hybridization here is sp3. That means it does not have a proper sp2 hybridization. It is inclined towards sp3 hybridization as well. So when, so mark my words, write it down here. For carbocation, if positive charge is delocalized, if it is localized, then there will be sp2 hybridization. And if it is delocalized, it will be sp3 hybridization. And this sp3 hybridization has tetrahedral. That means it is not planar, right? So whenever positive charge is in the delocalization, it is in the resonance, that means that is having sp3 hybridization. So it won't be planar. Understood? Understood? Yes, very good. Don't worry. Have you understood this thing? Understood this thing? If this is localized, then it is sp2 hybridization. If it is delocalized, that will be sp3 hybridization. Understood? Yes? Okay? Oh my God. Oh my God. Where are you all here? Where are you all? Just, I don't know where are you all. I sometimes feel like, why am I here? Right? Why am I teaching if you're not interested only? Right? You ask for, ma'am, we want this, ma'am, then we want this. And after that, when the lecture is here, then you are not here. So, don't worry, I'll teach. Okay, so then we have carbonyl, right? Then we have carbonyl. For carbonyl, you will have localization and as well as delocalization. For example, you have CH3 negative cation here. You have CH3 negative cation, anion here. Okay, so what will be the hybridization of CH3 negative and what will be the hybridization of CH2? This is negative, single bond, this is CH, double bond, this is 2, 3, 4, and this is CH2. What will be the hybridization of this? In this, as you can see, the hybridization will be 3 single sigma bonds and 1 lone pair. Negative charge is also kind of lone pair only. In negative charge, 1 electron is from itself and 1 electron is from the another atom. For lone pair, the two electrons in the lone pair is of that carbon, that atom only, right? So this is 3 plus 4. So the hybridization here is sp3 hybridization, right? 3, 4. Yes. The hybridization here will be sp3 hybridization. And what will be the hybridization here? What will be the hybridization here? What will be the hybridization in this form? So if you talk about this thing, here also, just give me a minute. I have written something wrong here. This is 1, 2, 3. Okay, but just let me mark this correctly. I have written something wrong here. Let me correct this. Okay, so this is CH2 positive. It has 3 sigma bonds. So this is sp2 hybridized. And this is also sp2 hybridized because it has 2 sigma bonds and 3 sigma bonds. 3 sigma bonds and 1 pi bond. Okay, so we don't consider pi bond. So this is 3 sigma bonds. That means it is also sp2 hybridized. So for positive charge for carbocation, both the localized and delocalized have sp2 hybridization. Both of these have sp2 hybridization only, sp2. Okay, correct this thing please. Both of these has sp2 hybridization only, right? Okay. Now, if we are talking about carbonyl, this has 3 plus 1, that is 4. Corresponding to 4, you have sp3 hybridization, and here you have 2 sigma bonds and 1 lone pair type, 1 negative charge. So it is having in total 3. Okay, so the hybridization here will be sp2. So you can write it down as, if the carbonyl is localized, then the hybridization is sp3. If the carbonyl is delocalized, then the hybridization is sp2. Understood? If the carbonyl is localized, that will be sp3. If it is delocalized, it will be sp2 hybridization. Right? But interesting thing is that, as we know, the condition here is complete conjugation. So we will always have positive and negative as well. We will always have sp2 hybridization only because they will be in the conjugation. As we know, conjugation means delocalization. So delocalization, positive or negative charges in the sp2 hybridization only. That means it will be planar. Understood? If it is a positive charge or it is a negative charge in the delocalization, that will account for the sp2 hybridization. Okay, perfect. So now let us understand what was cyclic. Cyclic means there will be a ring, right? That is very simple. So now let us understand. I'll do this when we'll start heterocyclic compounds. Okay, we'll understand this back then. Okay. So now you have benzene. You have benzene, right? This is benzene. You draw the structure like this, right? We all know benzene is the most famous aromatic compound. Now, why it is called aromatic compound? Because it follows some conditions of aromaticity. So, what are the conditions of aromaticity? First is PCC. PCC means planar. Can you see all these carbon are sp2 hybridized? That means this is planar. If I see planar, if I see cyclic, is this cyclic? Yes, it is cyclic. Is this having complete conjugation? There are alternate double and single bond. That means it is having complete conjugation. So I'll say all these things are followed here, right? Okay. Now, if PCC is followed, now what will be the chart to understand if that is aromatic, non-aromatic or anti-aromatic? See, if you have PCC, so PCC is planar, conjugation, complete conjugation and cyclic. If it is following PCC, then you will say it is, if the PCC is followed, then you will say either it is aromatic, or it is anti-aromatic, only these two things. And if it is not following PCC, you will say it is non-aromatic. You don't need to see other conditions, okay? If it is not following PCC, simply it is non-aromatic. If it is following PCC, it is aromatic or it is anti-aromatic. So now, how to understand if it is aromatic or anti-aromatic? For that, we'll have Huckel's rule. So guys, Huckel's rule say that if you have 4n plus 2 pi electrons, then it is aromatic. And if you have 4n pi electrons, then it is anti-aromatic. Understood? It is anti-aromatic if 4n pi electrons. If 4n plus 2 pi electrons, then it is aromatic. Understood? Now, what is the stability order? The stability order is aromatic are most stable, aromatic, then you have non-aromatic, and then anti-aromatic. Anti-aromatic is the most unstable compound. Nobody in this world, no compounds wants to be anti-aromatic. They are so unstable. They are very unstable. That is the reason so many reactions are not able to occur. The reason is if the product is anti-aromatic, the reaction will not happen. Okay? Understood? So now let us see some examples. Let us understand this with the help of examples. So this is the first example. That is, you need to check the aromaticity. Let us practice these questions. Okay? So, is this following PCC? Firstly, we have to understand, is this following PCC or not? For PCC, is this planar, positive in delocalization is sp2, that means it is planar. Planar, double bond, planar. Okay, these two, all these have sp2 hybridization, so planar, right? So, planar, then have complete conjugation. Yes, is this cyclic? Perfect. So, it is following PCC. Then we have number of electrons. So, it has 2 pi electrons. And always remember, while calculating pi electrons, what all you have to include is first is what all you have to include. First is the pi electrons in double bond, the electrons in the double bond, then lone pair or negative charge. Okay, so these are the pi electrons that you will include, right? Okay, so let us understand this. It has just one double bond, that means 2 pi electrons, and 2 pi electrons means it is having 4n plus 2 pi electrons if you put n is equals to 0. That means this is aromatic. So now this accounts for aromatic. Next here is, now tell me about this. Very good evening, bacho. Very good evening. So what about this? It is having 1, 2, 3, 4 pi electrons. 4 pi electrons means that this is anti-aromatic. This is anti-aromatic. I write it as AA. Okay, this is A. This is aromatic. Okay, this is AA. It is anti-aromatic. Understood? Yes. Very nice. Now next is, this is A, this is B, and this is C. Tell me, what is the hybridized? What is the which of the following are aromatic? Which of the following are anti-aromatic? Which of the following are aromatic? Which of the following are anti-aromatic? Yes, very good, very good. So this is 2 pi electrons. Every compound here is following PCC, right? Planar, all of these are planar, complete conjugation, cyclic. Perfect. Now, next is the calculating the pi electrons here. There are 2 pi electrons. Here we have 1, 2, 3, 4, 5, 6 pi electrons. As I told you, you have to include the pi electrons in the negative charge as well. Right? 2 electrons here, 2 electrons here. Total accounts for 6 pi electrons. And here we have 1, 2, 3, 4 pi electrons. Right? Okay. So, for this 2 pi electrons, what you have for these 2 pi electrons, that means it is, what do you mean by this? 2 pi electrons means it is following 4n plus 2 pi electrons, 4n plus 2 pi electrons, that means it is aromatic. This is following again 4n plus 2 pi electrons, that means this is aromatic. This is following 4n pi electrons, that means this is anti-aromatic. That means this is anti-aromatic. Understood? Perfect. Very nice. Very nice. Now coming to next, we have, this is A and this is B. This is A and this is B. Are you able to calculate the aromatic and non-aromatic character, everyone? Are you able to calculate the aromatic and non-aromatic character here? Are you able to do that? Are you able to do that? Everybody in the chat box, are you able to calculate the aromatic, anti-aromatic and non-aromatic character? Firstly, you have to understand the PCC, that is planarity is followed here. There is complete conjugation, they are cyclic. Okay, PCC is followed, so it is not non-aromatic, right? First thing. Now, anti-aromatic and aromatic, you have to understand, you have to apply the Huckel's rule here. Here we have 4 pi electrons. Here we have 1, 2, 3, 4, 5, 6 pi electrons, right? So for this we have, this is anti-aromatic and this comes to be aromatic as it is following 4n plus 2 pi electrons, right? Okay. The speed is perfect or is it going fast? Tell me. The speed is right? Or should I a little bit slow down? Tell me. Should I slow down or the speed is fine? Everyone, what are you doing? The energy is so low, bacha. The exam is not tomorrow, okay? Just take a chill pill. This is a very interesting topic. Don't make it boring, please. Don't make this topic boring. It's a very interesting topic. Okay? So now this is PCC. That means planarity. And after that cyclic, after that conjugation, complete conjugation. Every compound here is following PCC. And after that, let us calculate the number of, let us see. You're always perfect. Thank you, Ji. Thank you. 2 pi electrons following Huckel's rule. Wait. 2 pi electrons. Achha, how 2 pi electrons are following Huckel's rule? But if you have 2 pi electrons, then tell me 4n plus 2 pi electrons, right? If you put n is equals to 0 here, then you have 4 into 0. This is math. 2 pi electrons. Then it is 2 pi electrons. Tell me. Yes. Okay. Seshna, is this clear to you? Just put n is equals to 0 and you will have 2 pi electrons for aromatic. Right? Understood? Okay. So now let us understand for this 1, 2, 3, 4, 5, 6 pi electrons, and here you have 1, 2, 3, 4, 5, 6, 7, 8 pi electrons. And so the answer will be, this will be 1, 2, 3, this is following aromaticity, this is following 4n plus 2 pi electrons, and this is following 4n pi electrons. Put n is equals to 2 and you will have 8 pi electrons. So this is anti-aromatic. This is anti-aromatic. Understood? This will be anti-aromatic. Perfect. Very nice. Now, for this, we have to understand something. For this, we'll be understanding something firstly. Okay. So, for nitrogen, understand this. Okay. Very important. Students usually get confused in this thing. So, tell me, if you have nitrogen, if you have NH3, what is the hybridization of NH3? Right? What is the hybridization of NH3? And if you have this N and this is bonding to some other atom and that is bonded to some other atom. Now, what will be the hybridization here? In these two cases, as you can see, this is localized. This is not involved in resonance. So let us write it as localized. And this is delocalized. This is involved in the resonance. It will give rise to one another resonating structure which will have this thing. One bond. Write it as NH2. Okay, NH2. Right, just to complete the valency here. This is A, this is B, and this will have lone pair here. Right? Okay, I would say not lone pair. This will have negative charge here. Right? Okay, so this is delocalized. Now, let us understand the hybridization here. For this, the hybridization is 3 sigma bonds plus 1 lone pair, that is 4. For 4, the hybridization is sp3. So we'll write it. Hybridization is sp3. Right? The hybridization here is sp3. That is 4 corresponding to 4. We have sp3 hybridization. And for this, we have, tell me about this resonating structure. You have 3 sigma bonds only. You don't have any lone pair in the resonating structure. That means the lone pairs are involved in the resonance. They are not available. That means we will not consider, whenever the lone pair is involved in the resonance, we do not consider that lone pair in the hybridization. That is why he will write it as the hybridization here is sp2 hybridization. Right? Okay. But the interesting fact is, always while calculating the aromaticity, anti-aromaticity, you will always have complete conjugation. That means you will never have localized nitrogen atom. You will always have delocalized nitrogen atom. Understood? Understood, everyone? Perfect. Very nice. Very nice. So let us calculate the... Wait, let me also tell you about the oxygen. For oxygen also, the thing is same. For oxygen also, if you have this oxygen which is bonded to two sigma bonds, it has 2 lone pairs, right? For this is localized, this is not involved in the resonance. And if you have an oxygen atom that is bonded double bondedly to one atom, right? And this one atom, this is bonded to one single atom. This is A, and this is bonded to another atom. Right? If it is like this, what will happen here? So this is localized. This is delocalized. I don't want you to cram all these things. That's why I am teaching you all this in a very elaborative manner. Right? So this is 1, 2, 3, 4. For 4, you have sp3 hybridization. And for this, you will have a resonating structure. Right? And whenever the lone pair is involved in the resonance, then we do not include that lone pair. And here, we will not include this lone pair in the hybridization because this lone pair is involved in the resonating structure in the delocalization. And that is why here we will have 2 sigma bonds plus 1 lone pair. That means 3, which means this is sp2 hybridized. So every time whenever oxygen is involved in the lone pair of oxygen is involved in the resonance, then only it has sp2 hybridization. Otherwise, it has sp3 hybridization. Understood? Understood, everyone? Perfect. Very nice. Okay. So now let us understand these two things. Now you will be able to understand these two things. Now you have 3 sigma bonds, so there will be 1 lone pair. It has 2 sigma bonds, so it will be 2 lone pairs here, right? So firstly, let us see the planarity. As you know, this lone pair is involved in the resonance. The lone pair will shift here, then here. So that means this lone pair is involved in the resonance. Similarly, with this lone pair, single bond, double bond. This lone pair is also involved in the resonance. That means the planarity is followed here. It is cyclic. It is having complete conjugation. So PCC is followed in both of these. Right? Okay? PCC is followed in both of these. Now, let us understand if PCC is followed, what are the electrons? Let us calculate the electrons here. This is having 2 electrons, 3, 4, 5, 6. Now, tell me. How many electrons will be involved here? How many electrons will be involved here? How many electrons will be involved here? How many electrons will be? How many pi electrons in both of these? Only calculate. Now, put a important point here. Important point here. Only calculate pi electrons which are involved in the resonance. And I would say calculate lone pairs. Calculate lone pair electrons in pi electrons which are involved in the resonance. Okay, so you have to calculate only those lone pairs which are involved in the resonance. Okay, not other bond you have to calculate. No other bond you need to calculate. Okay, so this is 2 electrons, 2 electrons, 2 electrons here. Only these 2 electrons are involved in the resonance. So we'll calculate only these two. 1, 2, 3, 4, 5, 6. So it will have 6 pi electrons. That means it is aromatic. For this, how many electrons? Perfect. There's 6 electrons. This electrons is not included as it is not involved in the resonance. So we will have 1, 2, 3, 4, 5, 6 pi electrons. Again, this is aromatic. So many of you, so many students, what they do is they calculate 8 pi electrons here and mark it as anti-aromatic. This is aromatic. Okay, this lone pair is not involved in the resonance. Now next is this one, A and B. Now calculate for this, everyone. PCC is followed here. How PCC is followed here? This is boron. This boron has incomplete octet. What will happen here? Ma'am, how complete conjugation is happening here? This boron is having incomplete octet, and that is why there will be back bonding involved here. Back bonding is the type of resonance only. Okay, so there will be here on this boron atom, there will be complete conjugation, right? Okay, so it is following PCC, and the electrons here are 1, 2, 3, 4. Here on the boron atom, there is no lone pair on the boron atom. It is having incomplete octet. That is why these pi electrons will shift here, or these pi electrons will shift here. That means back bonding will happen. I'm writing it here. There will be back bonding. There will be back bonding in this. Okay, there will be back bonding. And now what we are going to do? Calculate the number of electrons. 1, 2, 3, 4 pi electrons. And for these 4 pi electrons, we will have anti-aromatic. Okay, this is following anti-aromatic. Understood? Yes. Gopika ma'am is saying, have you marked your attendance? No, Gopika ma'am. These students hardly any, there are many less students, they are very consistent. Not all the students are very consistent. I have seen that. Sometimes they come, sometimes they don't come. Then they say, okay, ma'am, we don't understand organic, ma'am. How to sharpen our organic? By attending lectures consistently. Okay. So guys, let us understand this one. Now, also another important point here. What is the important point? You know, here there will be 1 lone pair on this nitrogen atom. On this nitrogen atom as well, there will be one lone pair. Now, understand this thing. Understand this thing. If you have one nitrogen and the double bond is linked to that nitrogen only, then these lone pair will not participate in the resonance. If you have one lone pair here and this nitrogen, and then you have A, then you have B, then this lone pair will be involved in the resonance. So if the double bond is directly bonded to the nitrogen atom, they will not participate in resonance. They will not participate in resonance, and these will participate in the resonance. Okay, understood? So if we talk about the resonating structure of these, the lone pairs will jump here, and this pi bond will jump here, right? And after that, wait a minute, this lone pair will jump here, the pi electrons will jump here. So this particular lone pair on this nitrogen number 2, the lone pair is not able to involve in the resonance. Okay, it did not get any chance to get involved in the resonance. So that is why we do not calculate. That is why while calculating the pi electrons here, PCC is followed here. But while calculating the pi electrons here, we do not calculate this. Yeah, you can write it as not involved in resonance. They are not involved in resonance. So we are not going to calculate this. There will be 1, 2, 3, 4, 5, 6 pi electrons, and it will be aromatic. Understood? Understood, guys? Why we will not calculate this lone pair? Because it is not involved in the resonance. It is not. Those students' aim is not aims. Perfect. Yes, totally. They are very confused in attending lectures also. Very disappointed. Very disappointed. So all those students who are watching this in recording session, I would highly advise you, because after this I am going to take the class on Tuesday and Thursday, 6 p.m. right? The time suits you very well, so please attend the sessions, right? The live in the live sessions you are able to ask doubts, right? I am continuously watching this chat and I am able to answer the doubts, right, instantly. But if you are watching the recording, there will be so many doubts left, and after that sometimes students feel okay, we are not able to understand. The reason is you don't attend live lectures, right? So okay, so let us understand this A, B, C. The lone pair is here also, the lone pair is here also, the lone pair is here also. But this lone pair, A and C, the nitrogen atom in A and C, the lone pair will not participate in the resonance. Why so? The reason is because nitrogen is directly involved in the nitrogen is directly bonded with the double bond, right? Even if you try, you won't be able to participate, make this lone pair participate in the resonance. That is not possible. You can draw the resonating structures, right? Okay. So what will happen? The PCC is followed here. Now let us understand the pi electrons. 1, 2, 3, 4, 5, 6 pi electrons here. This is not participating, so we are not going to include it. This is participating in the resonance, so we are going to include this. This is not participating in the resonance, so we are not going to include this. This is 6 pi electrons. This is 1, 2, 3, 4, 5, 6, 7, 8 pi electrons, and this is 1, 2, 3, 4, 5, 6 pi electrons. I think this and this are same. A and C are same. Oh. A and C are same, bacha. A and C are same. What to do, ma'am? We can just cancel this. Okay, this is not involved, this is involved. So this will be aromatic, this will be aromatic, and this will be anti-aromatic. Understood? Yes. Localized lone pair, it is present in different p orbitals. Ames, very nice. AC aromatic, B is anti-aromatic. A and C are same. Okay, so this was about aromatic, non-aromatic, anti-aromatic. Now we are going to study enolines. Okay, now we are going to study enolines. What are these enolines? They are basically what? They are monocyclic. They are monocyclic rings having alternate single and double bonds. bonds. What they are? They are monocyclic rings having alternate single bonds and double bonds. What they are? Monocyclic rings having alternate single bond and double bond. And about this 4 represents the number of carbon atoms. The number of carbon atoms in them. Understood? So now, if I talk about drawing this 4 annuline, what you will do? You will just draw a monocyclic ring having 4 carbon atoms, and after that draw alternate single and double bonds. This is double bond, single bond, and this is double bond. Now tell me, is this aromatic or this is anti-aromatic? Everyone, is this aromatic or this is anti-aromatic? This is having complete conjugation, this is planar, this is cyclic. PCC is followed here. The electrons are 1, 2, 3. Wait. 1, 2, 3, 4 pi electrons. That means this is following 4n pi electrons. That means this is anti-aromatic. So they can ask you in the exam, what is 4-annuline? Anti-aromatic, non-aromatic, none of these, or something like that. Okay. So this is anti-aromatic. Understood? Yeah. Now coming to next is 6-annuline. Guys, everyone in the chat box, 6-annuline is very famous annuline. A very famous and one of your favorite annulines. What is that? 6-annuline is what? 6-annuline is 1, 2, 3, 4, 5, 6. Okay, then alternate single and double bond. What is this? This is benzene. 6-annuline is nothing but benzene. It is aromatic. It is having 1, 2, 3, 4, 5, 6 pi electrons, and always remember this number is actually indicating the, for annulines, this number is actually indicating the pi electrons also. Okay, this is 6-annuline, so this will be 6 pi electrons. Also, you can calculate 1, 2, 3, 4, 5, 6 pi electrons. So it will be aromatic. Okay, this will be aromatic, right? Okay, yes. Annulines is anti. So now, let us draw 8-annuline. 8-annuline. Let us draw 8-annuline. Okay? Okay. So this is 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8. Yes. This is 8-annuline. You can draw alternate single and double bonds. Now, tell me, is this aromatic? Is this non-aromatic? Very good. Very good, Sheshadri. Very nice. Very nice. Very nice. Perfect. Very nice. Okay. So what we understood from this? So this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8 pi electrons. You will see, ma'am, this is anti-aromatic, but that is wrong. Why so? Because it has a tub-like structure. That structure here is like this. The structure here is like this. Okay, it exists as a non-planar tub-like structure. Tub-like structure. It exists as a non-planar tub-like structure, and when it is not following P, that means it is not planar, that means it is non-aromatic. It is non-aromatic, right? So I will write it here also. It is non-aromatic. Why it is non-aromatic? Because it is actually not following the planarity condition. It is actually having tub-like structure, and that is why it is, yes. Don't worry, you will not do that mistake after this, right? Okay, so always remember, this has tub-like structure, that is why it is non-planar. When it is non-planar, then it is not aromatic, not anti-aromatic. You don't need to calculate the electrons involved here. It is just non-aromatic, okay? Okay, perfect. Now, let us understand this. Name this bacha. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10 annually. This is 10 annually. Now, one student here marked that, ma'am, 8, 9, 10, 11, 12 are non-aromatic. Oh, sorry, 8, 9, 10 told you. 8, 10, 12 are non-aromatic. Okay, so let us find this. Why they are non-aromatic? Ma'am, if I calculate the electrons here, it is 10 pi electrons, and then that is following 2n plus 4n plus 2. This should be aromatic. Why this is not aromatic? What is the reason? The reason is angle strain. Understand this very carefully. This particular carbon and this carbon, they have to complete their valencies by one hydrogen atom. As you know, this is sp2 and this is also sp2. So what will happen? They want to adapt a trigonal planar shape. That means one bond here, one bond here, one bond here, right? The shape will be like this. One bond here, and one bond here. That will be like a Y, right? Like this. This will have 120 for trigonal planar. They need to have 120 angle between them. And for that angle, what they do, they'll have one hydrogen atom here and one hydrogen atom here. If I am drawing it here, one hydrogen atom here and one hydrogen atom here, right? So what will happen here? Because we cannot draw it like this. Because this is not a 120 degrees angle. For trigonal planar, we need to maintain 120 degrees angle, and that is why one angle here, one bond here, right? Two hydrogen atoms. Now what will happen? The steric hindrance, repulsions will happen here. Angle strain will occur, right? Because of this, they will try to adjust their hydrogen atoms. What they will do? They will try to adjust their hydrogen atoms, and what they will do? For example, wait a minute. For example, the hydrogen atoms are like this, okay? One hydrogen atom is here, another hydrogen atom is here. Because of this angle strain and repulsions between these two hydrogen atoms, what they do is they jump out of the plane. These two hydrogen atoms will jump out of the plane to maintain the angle strain, because they don't want any angle strain. To maintain the angle, they don't want repulsions. That is why they'll jump out of the plane. These two hydrogen atoms will not be in the plane, and that is the reason. That means it will be like this. It will be like this will be hydrogen here, and this will be drawn as this switch. One will be here, other will be here, right? This will be out of plane now. So because of this, this will be a non-planar compound, and when the compound is non-planar, that accounts for non-aromatic. Understood? That accounts for here comes the chalk. Understood? Yes. Okay. Perfect. Very nice. Yes. Transangular effect. Very nice. Okay. Basically angle strain, you can say. Right. Okay. So now you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have 12 annually. So now what will happen here? Again, because of angle strain, because of that only concept, what will happen here? One hydrogen will be here, one hydrogen will be here, one hydrogen will be here. Because of the angle strain, they will jump out of plane, and that will be non-planar. And because this is non-planar, this will be non-aromatic. Understood? This will be non-aromatic. This is clear to everyone. Okay? This will be non-aromatic compound. Yes. Perfect. No 7 aniline. Okay? Just in even numbers. Understood? Now, understand next. Then we have 14 aniline. What is this? You can calculate this as well. This is 14 aniline. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Right? Number of carbon atoms, 14 aniline. Now, let us see, is this non-planar or not? One hydrogen atom here, one hydrogen atom here, one hydrogen atom here, one hydrogen atom here. So in this particular, from 14 aniline, you will not have any steric hindrance, and that is why this is planar. This will be planar. This will follow PCC. That means complete conjugation, and it is also cyclic. So what will happen here? Let us calculate the number of pi bonds here. The pi electrons here. It has it has 7 bonds, so it will have 14 electrons. So I'll just write it as 14 pi electrons, and that will be 4n plus 2 pi electrons, right? Both it 12 plus 2, right? So this will be aromatic. This will be aromatic compound. This will be a aromatic compound. So too much space, so no. Ma'am, I am not sir. Bachcha, I am not sir. I am ma'am. Ab batao. What is this? What is this? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. This is 16 annually. This is 16 annually. And what will be the, as you all can see, there will be so much space. I have drawn it in a concise manner. There will be so much space for these hydrogen that this also will be planar. This also will be planar. And that is why PCC is followed. And it has 16 pi electrons, and for 16 pi electrons it is following 4 and 5, that is 4 into 4, that is 16 pi electrons, and that is why it will be anti-aromatic. It will be anti-aromatic. Understood? Yes, it will be. Yes. Okay. Okay, cool. Got it. Shishadri. Got it. Yes, perfect. Too much space? No, so no. SIR. Sir. Very nice. So now what will be the name of this? This is 18 annually. This is 18 annually. 18 annually. So it will have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18 carbon atoms here. And how many pi bonds? As you can see this. How many pi bonds? 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? 9 pi bonds. That means 18 pi electrons only. 18 pi electrons only. And will this be planar? This will be planar. There is so much space. So no steric hindrance. So much space. No steric hindrance. So this will be planar. And it will follow PCC. And that is why we will say this is 4n plus 2 pi electrons, and that is why it will be anti-aromatic. This will be anti-aromatic, not aromatic, bacha. This will be anti-aromatic, right? This will be anti-aromatic. Understood? Understood, everyone, why this will be anti-aromatic? Clear to everyone here? Perfect. Very nice. Now, let us do some questions based on it. Very, very important questions. Some different questions, right? Okay, let us do these questions. Okay, so let us do these questions. Okay, so now they're asking which bond will be cleaved first. You have these two things, right? So here, how you will proceed? How you will do this question, right? Firstly, break this bond. As you know, this is more electronegative. This is carbon, this is carbon, this is oxygen. Carbon is more electronegative, so it will take away these electrons. So what will happen here? How many electrons will be here? It will be like this. It will be like this. It will take away the electrons here. So it will be, this will be O negative and this will be positive. And here it will be, here also it will take away the electrons because oxygen is more electronegative. It will be like this. It will be like this. Right? Aromatic. Okay, so sorry. Yes, this is aromatic. So sorry. It is aromatic. Condition is right. Yeah. It is aromatic. Ma'am, 18 atoms N is equals to what they followed by yes. I have written the right rule, but by mistake. Okay? By mistake. Yes. It is aromatic only. Yeah. Okay? Done? Yes, thank you so much for correcting me. Now, let us see this question. This pi electron will be shifted towards a more electronegative atom. The structure here will be like this. After the bond cleavage, the structure will be this. Now, let us calculate which of these is aromatic. Right? Okay. So, this is 1, 2, 3, 4. This is 4 pi electrons. You just need to consider this thing. Okay. This will be, here it will be 2 pi electrons. So, You know, 2 pi electrons means it is aromatic and 4 pi electrons means it is anti-aromatic. As I told you earlier, nobody wants to be anti-aromatic because it is very unstable. So, this particular, if I name it as A and this is B, the B reaction will occur fast. B reaction will occur fast as compared to A reaction. A reaction might not happen only because nobody wants to cleave its bonds and go to anti-aromatic stage because it is very unstable. So that is why B reaction will be fast as compared to A. B reaction will be fast as compared to A. Okay? Right? Very fast as compared to A. Understood everyone here? Understood everyone? How do we proceed with this question? If they have asked you which bond, which reaction will be fast and the structures are like this, just cleave this bond and draw the structure and then calculate which is aromatic, which is anti-aromatic. Understood everyone? Understood? Understood? Yes. Okay? Next. Okay. So now they are asking again which bond will break first. Okay? Which bond will break first? This is A and this is B. Here, in the previous question, you had this more electronegative atom in comparison to this carbon. But in this stage, you don't have more electronegative atom. This is carbon and this is hydrogen. Here, carbon is more electronegative. So the electrons will jump here. The electrons will jump here, not to hydrogen, right? So, after the bond cleavage, what will happen? After the bond cleavage, what will happen? This will be two bonds and the negative part will be here. There will be H positive somewhere, right? And here also, the bond negative will be here. Understood? Understood? Yes. Yes. Okay? So now, bacha, this is the last question. Okay? Don't worry. This is the last question. Everything you want 2x speed. Right? Okay. So bacha, let us calculate the electrons here. 1, 2, 3, 4, 5, 6 pi electrons. Right? This is 6 pi electrons. And here we have 4 pi electrons. So means this is anti-aromatic and this is aromatic. So this reaction A will be faster than B. A will be faster than B if we are talking about these kind of compounds. Understood? If we are talking about these kind of compounds, A will be faster as compared to B because in A you have aromatic and in B you have anti-aromatic. So if the bond wants to cleave, then it will go to aromatic thing then rather than anti-aromatic. Okay? Now, let us see one another thing. If they have asked you which is more acidic out of these two, which is more acidic? Acidic means the ability to lose H positive ion. The more the ability to lose H positive ion, the more will be the acidity, right? So this will lose H positive ion more easily as compared to B. So A is more acidic. You will say A is more acidic than B. Understood? Understood, bacha? Understood? Yeah, there is one another example also. One more example. Yes. Many did not know basic it should be benefited. Very good. Shadri is a very sweet person because she is thinking about everyone, just not very selfish and thinking about only herself. That okay. Right? You are in a class. This is not a one-on-one session. Understand this. Okay. So guys, let us calculate which bond will break. Will this bond break like this, that the electrons will move here, or this bond will break like this, the electrons will move here? What will be the right condition? This is A and this is B. Tell me fastly in the comment section which bond, the pi electrons will move upwards or downwards, right? So there are two things, right? There are two things. The first case and this is the second case. In A part, you will see the electrons are moving towards this ring. So there will be one negative here and two pi bonds here. And this particular is electron deficient. This carbon will be electron deficient. So I put this positive here. And in this case, in the B case, this is A case and this is B case. In the B case, the electrons are moving towards the smaller ring. So this will be negative here. And the electrons are moving away from the larger ring. So there will be a positive. This will be electron deficient. Right? So it will be things like this. Now, what will happen? This is 1, 2, 3, 4, 6 pi electrons. This is 2 pi electrons. This is 1, 2, 3, 4 pi electrons. And this is 1, 2, this is also 4 pi electrons. So now what you will see, here we have aromatic, and this is also aromatic. This is anti-aromatic and this is also anti-aromatic. So now what you understood from this? If the reaction is proceeding towards anti-aromaticity, then the reaction will not occur. Okay, if the reaction is proceeding towards aromaticity, then the reaction will occur. Okay, so A will occur. Okay, A reaction will take place. A reaction will take place. Understood, everyone? A reaction will take place and B will not take place. A reaction will take place, B will not take place. Yeah, you though I know very well. You are very late because I am almost done with this topic. This topic is over, right? This was the last question. This was the last question. So guys, any problem in today's lecture? Any problem in today's lecture? Any problem? Any problem, anyone, everyone? Any problem? So firstly, let us understand the timings. What we will do? Tuesday and Thursday. Tuesday and Thursday, you will have your class at 6 p.m. Right? You will have your class at 6 p.m. And in the next lecture, we are going to do, on Tuesday, we are going to do stability. This is the last lecture of GOC. Stability of intermediates, acidic and basic strength. Acidic and basic strength. This lecture is the nutshell of all the things that we have done till now, right? All the things will be applied on this lecture. Tuesday 6 p.m. All the things that we have studied till now will be applied. The application part we will discuss in this lecture. There will be so many questions, acidity, basicity, and short questions will be asked from this particular lecture directly. Questions will be asked. So I am telling you, join this lecture 6 p.m. Tuesday. Okay? Understood? Yes. What is your problem? Yes, okay, Saravni, I'll definitely do the practical chemistry. Don't worry, I'll definitely do the practical chemistry, okay? I have that in my mind. And one more video will be coming where I'll discuss about the experiments that are in the practical chemistry and from where you need to do the experiments. Okay? Yes. Thank you, Bacha. Thank you. So what we will do, this lecture is going to be very important. So book your slot for Tuesday 6 p.m. Be free at 6 p.m. Okay? Yes, I have decided the time according to your convenience only. Also, let us write the homework here. So your homework is, I know, the homework from so many sessions. I need to discuss that homework, right? So I'll discuss that homework after stability and intermediates. After the Tuesday's lecture, I'll discuss the homework for all the lectures till now. Okay? Right? Okay. Yes, Bacha, I'll definitely do the hydrocarbons. It is already going in Hindi and I also do that in English. Don't worry. Okay? So I'll need more of your time for hydrocarbons because it's a very important lecture. Right? So, for homework, we have okay. Okay. Just wait. right? Okay, is this aromatic? Or find the aromaticity or anti-aromaticity, A. And then there is B. For B we have okay. Find the anti-aromaticity or aromaticity or non-aromaticity of E and D. Understood? Okay. What did I forgot? Tell me. Thank you so much. Thank you so much. Thank you so much. So guys, after this lecture, Tuesday 6 p.m., please do read. Please have a look at all the notes we have done till now. Stability of intermediates and acidic and basic strength is totally dependent upon inductive, resonance, aromaticity. All of these concepts will be applied on that lecture. So if you're telling me, will tell me in that lecture, ma'am, we don't know how to do aromaticity, how to find the hyperconjugation structure, then there is no use of stability of intermediates and acidic and basic strength. For that lecture, you have to revise all the things that we have done till now. Okay, ritual of one word. Okay, so guys, everyone, tell us one word from your language. One word from your language. One word of Malayalam. One word of Malayalam. Yes, Malayalam word. Anyone? One word of Malayalam. What is the word? What is? Tell us some easy word, okay? Some easy word. Fast. Just thinking, okay, what word should we tell? What word should we tell? Just an easy word, okay? Nancy is very curious. This week test link will be, bacha, that will be active in the Telegram channel. And also do give the test, okay? Do give the test. If you're not practicing your theory, then what's the point of doing any theory part, okay? Practice and then analyzing the things, that is very important if you want to succeed in, like, if you want to clear NEET and also want to get good marks in NEET. They're just thinking. No one here. Answer me, ma'am. You will complete all chapters, right? Please tell me. Yes, bacha, I'll complete all the chapters. Don't worry, I'll complete all the chapters. Even if I have to take 4 or 5 hours class for one chapter, I'll complete the syllabus, okay? You just need to be there for 3-4 hours if you want the syllabus to be completed. Is there? I think there are no Malayalis here, so we need to connect to Gopika ma'am for that. Okay, we need to connect to Gopika ma'am. Okay. Okay, I think there's no Malayalis here. Class Ishtamyo. What does that mean? Ishtamyo. Can you ask Gopika ma'am? So I'll ask her and I'll tell you. There's someone, Sneha is saying something. Great to hear, ma'am. Okay, perfect. Ishtamyo means, what does that mean? You like my class. Okay. Okay. So is that I'm asking this or I'm saying this? Adipoli, it's my favorite word. Adipoli. Super. So Ishtamyo means, I have not understand what does Ishtamyo means. Is it a question or is it an answer? Adipoli, I know Adipoli. Oh my God, tell me. Oh my God, you're making me feel sleepy now. Okay. Slow diapers. Yes. Do you like? Okay. Istamyo means do you like? Okay. So guys, do write it in the comment section if you liked my class or not. Istamyo, class Istamyo or not. Okay. Okay, then bye-bye. See you all on Tuesday, 6 p.m. And that is going to be a very important lecture. So do not miss that lecture in any case. Bye-bye. Take care. See you all.